Okay. All right. So there's the liquid. After liquid, what's the next one?
Plasma.
Oh, no, plasma is not next.
Gas.
Gas is next. All right. When I think of gases, I think of clouds. The kahuna gas is, a cloud is basically kind of a gas you can kind of see. And after the highest amount of energy state is plasmas. Plasma. And what is that drawing supposed to be?
A lightning bolt.
Lightning bolt. So these are our 4 states of matter, and we've put them in order of energy. So the one at the bottom has the lowest energy, and the one at the top has the highest energy. And that's important as we go through these transitions. All right? Now, if I have something that's going from a solid to a liquid, what is that change of state called?
Melting.
Melting is correct. It's from a solid to a liquid. Melting is the term that you'll need to know. Does energy have to go in or come out in order for this change to happen? Yeah. Come out?
Come in.
So do you get energy when you go? It has to get more. So if it gets more, it has to come from the room. All right? So energy has to go in to make this happen. Does this make some sense? Because solid is like you in this room. You're all in nice, neat little rows. You have low energy, and you're just kind of like, mess with your glasses and tap your foot and write stuff, but you don't move very much. A liquid is like you in the hallway. You move past one another. You're not stuck in a particular place. You're flowing from one place to another. All right? So all of that happens to be an energy change. Is the hallway more or less energy than this classroom?
More.
More. So that energy has to go in to go from a solid to a liquid. If energy goes in, that is called endothermic. That means this change from a solid to a liquid is endothermic, because energy goes in. Okay? When you go from a liquid to a gas, what's that called? Yeah.
Evaporation.
Evaporation is kind of right.
Vaporization.
Vaporization is the word I'm actually looking for. Okay? Here's the thing. From a liquid to a gas is called vaporization. And there are 2 types. One of those types is evaporation. And the other type is? What's the other type of liquid to a gas?
Vaporization.
Vaporization is the big generic one, of which there are 2 types.
Is it Never mind.
Okay. It is not. I will give you a hint. It's happening in the room right now.
Oh.
What's this?
Steam.
Boiling. Boiling is going from a liquid to a gas. So there are two types of vaporization: evaporation and boiling. Boiling happens throughout the liquid. All right, let's take a look at this for a sec. Got some water here. It's boiling. It is going from a liquid to a gas throughout the container. You got little bubbles in there that are gas. Does that make sense? What kind of gas is in the bubbles? Yeah.
Air.
Okay, air is a common hypothesis. What else could it be? What?
Steam.
Steam's a common hypothesis.
Carbon dioxide.
Carbon dioxide, I get quite a bit. The four most common answers when I ask that question are air's in the bubbles, oxygen's in the bubbles, hydrogen's in the bubbles, or steam, which is water, is in the bubbles. I occasionally get some carbon dioxide or nitrogen's in the bubbles. I'm going to tell you right up front, carbon dioxide or nitrogen are really highly unlikely. They just don't, it's not going to, it's our least likely scenario. Okay? So let's talk a little bit about those four gases that you think it might be. Yeah?
It could be pressurized air. Pressurized air.
In order to be pressurized air, doesn't there need to be like a lid on it to create pressure? Okay. So we're looking at air, hydrogen, oxygen, or water. Well, there's a test we could do to figure this out. In air, what does a match do? Burn brighter, blow up, or go out? It just burns. In oxygen, it burns brighter. In hydrogen, it blows up. And what do you suppose a match does in water?
Goes out.
It goes out. So our four most common ones are air, hydrogen, oxygen, water. And the easiest way to find out is hold a lit match over it. Because you guys all see how there's like all that stuff's right here? So if I put a match in that, it should do something. Alright? So here's what a match does in air. Let's see what it does in that.
Why are you doing?
Because if it's hydrogen, what's going to happen?
It's gonna go boom.
You don't even have
goggles on.
Or go out.
I was right.
Are we sure that's what's going to happen? Let's try one more time just in case.
Evaporation.
Oh no.
Or you want it, I feel like you want it to explode.
It's gonna finish
That's science class.
if it goes at all. Pop that jack. It's Yoda.
She touched to the side.
You
No, I didn't.
Oh, you did?
No, I didn't touch it.
Stuff.
Didn't touch the water in the container, and I didn't touch the side.
No,
And yet,
no explosion.
it goes out.
I want to see it explode.
So that means that the little bubbles, the stuff in the bubbles, is water.
Water and water.
It's just burning water. The heat.
Now, some students, they really have a hard time with that idea. That the idea that the stuff in the bubbles is water. And so let me kind of point out to you how that works.